Hi, everybody. This is Ms. Medrano, and I'm going to talk to you about constant speed wrap-up. All right, so our key question was, what is constant velocity? And we'll be answering this question using CER, which we've been practicing since Unit 1. All right, so what is constant velocity? Let's go through the evidence and the reasoning before I answer before I write the claim of what constant velocity is. But first things first is that you really should have seen your bowling ball move across the track. And here's a flag on your Pivot Interactives. So the bowling ball moved across the track in what was constant speed. All right, so your bowling ball, in fact, did move using constant speed. Now, some of you might have taken your data like this, where you took time first and then your position second. All right, so if I took time first, this is what my time looked like. So at 0.5, it was 25, and then 50, whoops, sorry. And then at 1.5 was 75, and then at 2 was 100. And I noticed that from 0 to 25, from 25 to 50, 50 to 75, and 75 to 100, it's all going up by 25. If I added 25 to each, then it's going up by that. And so I'm going to say, right, in my evidence that so my group and I took equal, we took the time at 0.5 seconds intervals and recorded the bowling ball's position on the ruler. All right, and then so we also wanted to say that we looked at the front of the bowling ball, and at every time we hit 0.5 seconds, and at 1 second, and then at 1.5, and then at 2, right, the bowling ball's front happened to be at 25, at 50, 75, and 100. And so what we noticed then, right, for every half second, the bowling ball rolled approximately 25 centimeters. Now, this was my data, and I don't think that your data would look the same. All right, so I made this data up. So you make sure you're using the correct data from the Pivot Interactives. All right, now that's one way of taking the data down. Another way of taking the data down is maybe you took the position first and then the time. All right, so maybe you did 0, 0, and then when the ball was at 20, you notice that the time said 0.39. And then at 40, and then at 0.8, at 60, the ball or the timer said 1.19. And when the ball was at 80, timer said 1.6. All right, so then here we would explain. We took the position of the ball and recorded the time it took to get there. And so from 0 to 0.39, we see that there's a 0.39 increase. And then from 0.39 to 0.8, we saw there was a 0.41 increase. And then from 0.8 to 1.19, there was another 0.39 increase. And then we are seeing some sort of pattern here. Now, your data is not going to be equally clean pattern like this, right? I made up this data to get my point across. So it says here for every 20 centimeters, the ball moved. It took about 0.4 seconds to get there. Right? And this is just summarizing up what our evidence looked like. Now, what this looks like, right, is we marked off the ball. So here is 0, and then 20, and 40, and 60, and 80. And so every time the ball got to a location, we recorded the time. So we saw that this was 0.39, and when the ball was here, it was at 0.8 seconds. And when the ball was here, it was at 1.119 seconds. And when the ball was here, it was 1.6 seconds. So that would take care of the evidence section. All right. Now, to get to our next part, the reasoning. Now, this is going to be one of the hardest things we'll do in physics is writing the reasoning. And it's going to be okay because you're going to have so much practice with it. All right, so sorry about the turning. The introductory statement would be, it sets the stage of the experiment. So describe your experiment maybe a little bit here. So what is it that you did? Maybe you took the time first and then recorded the position, and then maybe you marked off the position and recorded the time. What is it that you did? Okay, so a short description of what you did. And then we will also say that the bowling ball was traveling at a constant speed. And then you're going to be explaining what it means to be a constant speed. All right, so then you explain your evidence. So then the explanation for this is the bowling ball, so I'll just say ball, moved the same amount of distance for the same time interval. Okay, and then more specifically, ball moved, or I'm just going to restate what we wrote, right? Let me see. For every 0.5 seconds, the ball moved 25 centimeters, or whatever your data is, right? My other data, right, my other pretend data said that for every 20 centimeters, it took 0.4 seconds to get there, or to travel, or whatever it is, right? Now, let's talk about what it means to move, what it means for something to move at a constant speed. And this is the part where it's kind of important, so I'm going to put it in the box. All right. And what it means to move at a constant speed is, okay, constant speed means that the object takes equal time to travel equal distances. All right, so notice here that I didn't calculate what the speed is of my bowling ball, right? I don't really care about what speed my bowling ball is going at. I just really care about what constant speed means. So let me just color this in because this is super important. Okay. So constant speed means the object takes equal time to travel equal distances. And then some examples of stuff that's not moving at a constant speed, right? So constant speed, as we talked about earlier, it was taking equal time to travel equal distances. So if this was 25, 50, 75, and then 100, it was taking 0.5 seconds to get here, and then 1 second, and then 1.5 seconds, and then 2 seconds. So the example of it not going at a constant speed might be this could be 10, then this can be right. And so then at 1 second or at half a second, it started off here. And then at 1 second, it started off. Then at 1 second, it was found at the 30. And then at 1.5 seconds, it was found at the 60. So then here we have equal spaces and equal time intervals. And here we don't have equal spaces, even though we have equal time intervals. All right, so then this would show that it's not moving at a constant speed. So let's go back to our claim. What does it mean what is constant velocity? So constant velocity means the object takes equal time intervals to travel equal distances. And hopefully your evidence and your reasoning should back all that up. So this would be your CER wrap up. And